Do you want to do that for the whole session?
I don't mind. Eh,
That's
like,
okay.
unless you want to like also try to solve your problem. That's valid part of such a session. Do you want to like at least take a look at the CLI, like stood error of Chrome or something, or maybe
Yeah.
the system, like the output from that screen share service? Maybe there's something there.
Except I can't share.
Right.
I can't share the debugging session. Okay.
Also, if you could switch to your headset again.
Oh. It might be because of Pipewire. I added the mouse loopback device. One.
Huh. I got you, but it's low. I can turn up on my side.
Wait. But is it from my headset mic?
It is.
Okay.
So what output do you have?
From XDG. No. What is it? XDG desktop.
Mm-hmm. Portal, something.
Desktop photo. Okay. Journal CTL dash user dash FEU XDG desktop photo. I mean, looks like some warnings, but nothing.
Anything serious?
Nothing relevant.
Did you try sharing again?
Yeah.
Because if you're using F,
Works now?
mm-hmm.
Okay. I didn't do anything. I swear I didn't do anything. I just checked journal CTL. Although I did restart but that was last time. Yeah. Okay.
You're listening to music?
No.
What is... Oh, that's input devices. What is that? Why is it like tweaking like that?
The level's too high. 1, 2.
Well, that's not the one you're using, is it?
Oh, yeah, this is the internal microphone, right? And this is the normal level. But it has like 30 dB plus amplification, I guess. Okay, let's get back to the thing.
Cool.
Yeah, it's because no, I don't have it anymore. I had also loopback device with a DSP processing some stuff here. Maybe that messed it up.
Hubba, 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 hubba. Now I see like a blank window from you. What is that?
No, it's
It's not
Codium.
frozen, but I don't know what it is.
It's
Do
Codium.
you,
It's supposed to be Codium.
do you see what I see?
Yeah, yeah,
The heck?
it's
What is it?
frozen.
It's not
Let's see
frozen,
if
it's throbbing. Oh no, the throbbing is
It's the
the
record icon.
studio.
Yeah.
All right. So um
Well, as soon as I opened Codium, it's uh yeah, it froze.
you think that's that's the culprit?
Or the terminal. One of I don't know.
Huh.
Maybe multi-screen.
What if you close it?
Close what?
Codium.
Oh, right. Closed Codium. And set it to one screen. Ooh,
I see again.
yeah. There we go. Okay.
What? I see terminal. I have Codium.
There we go.
What? Did we figure anything out?
Uh,
I'm
I
not
don't
even
know.
sure that it was triggered by opening Chromium at this point.
No, it was a like terminal or time based or screen switch maybe. Because I
Screen
switched that,
switch?
not screen, desktop switch. I switched to a different desktop.
And what desktop are you on now?
Two, maybe? Yeah, it's two.
Because it's frozen. Try switching again.
One. Oh, it's frozen again.
Switch more.
Nothing.
What? Huh.
Huh.
Shut Codium.
I did.
Shut something else down.
Nope.
Okay. I don't know. I'll share and you will hopefully. I mean, you can test this without me, right?
Yep.
Hopefully you'll have time to do that. Uh,
Sorry.
do, 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 do. Okay, not cool, not cool, but we can work with it. Here's rxRust. So pick an operator.
How about we go through map again?
Map. Sure. Here's map. Here's the operator struct. It has source and f, no constraints. Here's the observer, map observer, has O and F, no constraints, which is one thing that is interesting that it's the func is on both. It's a field on both.
Mm-hmm. Hmm. Uh. Huh.
But maybe this is consumed. We'll see. So here's observer for the map observer. Okay.
Yeah.
And in it, the implementation wise, it's just self observer next. Right? It's
Mm-hmm.
this, right?
Yeah.
Self observer next. So an observer holds an observer in this case and just goes next and then using that function. Okay?
Yeah, but next takes a function. No.
No, no. It's the
No.
Function
This is a function
calls
call.
function call with v, and then right,
Why
that's what
is
map is.
the extra parent brackets there? Cheers.
No method
Okay.
named func. To call the parameter stored in func. To call the type parameter stored in func, surround the field access with parentheses.
Wow. Wow.
I don't know why it's here though, the type error. So there.
So
Error.
why does it need to be surrounded? I didn't get that.
It's we're calling I don't know. I mean, this syntax without parentheses is like method call, and method call is not field access. This is field access. So maybe we need to like separate field
yeah. Got
access
it.
and then do method, then do call.
Got it.
Right?
Because that's a field that's a function and not a method. Got it. Mm-hmm.
Error is forwarded, and complete is forwarded. Okay.
Mm-hmm.
Is closed is forwarded. And in order to do that, we need to say that O, right, which ends up being observer here, is an observer of out and air. Some
Yeah,
out and
so
air.
these are trait bounds on the implementation.
Yes.
Yeah.
And the F, which is func, is fn mute, takes item and turns out.
Yeah.
Notice the relationship between this out and that out.
Yeah.
So the observer is the observer going out, right? Like it is whatever observer, like observers hold the observers that observe them. Does that make sense?
Uh-huh. Mm-hmm.
Observers hold the observers that observe them. This trait is purely type. It's a type trait, no methods. I cannot explain the type design here.
Mm-hmm.
That's just the observation. And it needs to be implemented for the thing that the method returns. Map method returns this. This is the operator struct.
So there's a map SF, and this is the implementation for observable type of map SF.
Right. Our goal, I think, our goal in implementing observable type is to declare type item and type air.
Yeah.
And that is done relative to these, right?
Yeah. That's
So
interesting.
if S is an observable type as well, and again, that'll be the source field, then we can say that the air is the same as the source air,
Mm-hmm.
but the item comes from the function. So here's F for some lifetime fn mute. It takes the item at that lifetime and returns an out, and type item is an out, which comes from here. Okay. And then this is where there's like slightly more, but in more complex operators, there can be even more. And this is the addition of core observable of C, because that's context. This is generic on context. Again, the trait bound is not here in this trait, right?
Yeah.
But this trait does require that observable type implementation. Oh,
Yeah.
okay. Of self. Sorry, I said self.
Of self. Yeah.
So that means that whenever we treat self here, we can obtain these, right?
Yeah. Item under.
Right. And at some point in the implementation, this C is context, if I remember correctly. No, sorry, here it's context.
Yeah. C is context. Yeah.
And before we look at the bounds, what we need to do here is declare the type unsub.
C is a context.
Mm-hmm.
Yeah.
And this is inherited from S unsub, which is the source.
Mm-hmm.
Observable. And subscribe. It's the only method. Required method for core
Gets a
observable.
context of a context type.
Right. It consumes self and it gets a context of that, this context, and returns the self unsub, which is like this, right?
Mm-hmm.
And then self here is destructed to get the source and func. This is just convenience, right? And then we use a method and a utility on the context that comes from the same from the context trait.
Yeah.
And all it does is like it gives you the context inner the observer, and then you can transform it into a new observer. That makes sense?
Yeah.
And we transform it into this observer. We keep the observer here and store the func as well. And this is what I said, right? That the func is, this self is consumed. And so the func is just like transitioning here,
Mm-hmm.
right? This is just a conveyor belt to get it here. Nope. It's not that funny. Which doesn't mean you shouldn't enjoy your little laugh.
No, that's okay. I'm just thinking about what else map is used for except for this let assignment. Oh, yeah, it's constructed via the map function, I guess. When you call the map function, it gives you a map.
Yeah, the map method that is explicitly declared on the context maybe?
Context.
Yeah,
Core
eventually
observable.
Context. Let's see. Maybe both.
Maybe.
So
yeah.
Here observable, right?
Mm-hmm. Mm-hmm.
Eventually observable. Yeah, you see, this is.
It transforms into a map.
This is on what? Observable. Not core
Observable.
observable.
Yeah.
The observable trait.
Core observable is just the core.
Yeah, that's why this is wrapping it. This is self with map.
Subscribe is an on-core observable. Or
both. There's
both.
So subscribe on core observable looks like this.
Yeah.
Sorry. No, like this.
Mm-hmm.
That it consumes self and takes context.
Mm-hmm.
But subscribe on What is
It's the
this?
same
It's the same. But subscribe on
context.
context. Yes. This. Or
Does
maybe on
context have a
observable.
subscribe?
Sorry, it's observable. How do I search? How do I search observable trait? I don't know. I don't know how to do this. Observable. No. Observable pub trait. Core observable. This one?
Core
The
observable
subscribe?
only has subscribe, and observable also has subscribe. But it's observable is a context. No.
Are you
What?
looking at my screen?
Yeah.
Oh.
Line 129. It says observable colon context.
That means that observable types that implement observable must also implement context.
yeah.
It's like a eager bound, right? It's a bound on self. Is it equivalent to like here, like if you do self context? Maybe it's equivalent to that.
And
Does that make sense?
that's only for the type item. That where bound is only on the type item. And this is on the whole trait.
Yeah. Oh no, you're right. Sorry. You can't do a where in the trait itself, right? Okay. So
That's already a. Oh.
this is the constraint. So back to subscribe method, right? You have one on core observable that consume selves and take context. This one consumes self and takes an F. That makes sense?
What's a F?
It's an FN mute.
For a FN. For.
It's like an observer, right?
Lifetime A, FN mute self item, lifetime A. For any lifetime. Oh, this is okay. So this is a parametric over lifetime. So it could work for static as well as no.
I don't
Value.
know what.
So that thing somehow makes it polymorphic over lifetime. So this single declaration works with static lifetime or like normal mutable reference or with regular reference.
Well, it's also about the like where the lifetime comes from. This comes from the function. So for example, if the function is like whatever implements FN mute, right? Because it is something that implements FN mute.
Yeah.
So it's bound to the lifetime of it. Does that make sense?
Of the parameter of item.
The
So
item.
the function's argument. The function's argument's inner type.
Yeah. Whatever. I'm hand wavy on this for stuff.
Yeah. Still trying to grasp it. I mean, I've come across similar mechanisms, but I don't know exactly how this works. And it's always a bit complicated because when you're doing like traits, you're programming a logical system. It's kind of like logic programming. Did you try Prolog?
No.
In logic programming, you describe the logical structure of the answer, or of the answer, and then usually it runs some kind of backtracking, trying to substitute values into variables. And it's cool because you can run your programs backwards, kind of, but it's also weird. It's like when you're trying to determine the type of an expression, you're trying to put in more and more concrete types into it. So like if you come across a plus, it means both sides are int. So any variable that's referencing those types becomes an int. And in logic programming, you try to substitute logic variables with possible values and exclude those that can't work. And in traits, you're trying to select implementations, and yeah, it's weird because it's not always clear what the input and what the output is. Right, I'm rambling again. Let's move on.
Well, my point is that's internal subscribe of the core observable is like it's an internal one. It's the actual subscribe, and these are just these are the API. You see that there's a subscribe that takes a fn mute, consume self, and takes an fn mute. And you see that this is already when context exists, right?
Yeah.
Right. So that's why this is the external API. And there's subscribe with. Okay. And here's map, right? That returns a self, which is some. So with comes from context. So self is as much as it is context with map. Does that make sense?
Yeah.
That's why here it's like self transform, right? Context to context, core, map, source, core. I don't know if core is a good word. That make sense?
I think it's because it's a core observable.
Oh, is it though? Maybe.
Uh,
I don't see anything about core observable here, but
it's in the
probably
function. It's in the
happens to be.
function type. Oh,
What, transform?
sorry, this is map. I was looking at the wrong function. Okay, so transform the core, which is like
Transform the
context.
context. Yeah, this is a context utility.
Yeah.
And this is a context method.
Yeah.
So every implementation of an operator.
It's not in context. It's observable, but observable is context.
I'm sorry, you're right. Observable, but observable is a context, therefore we can do self-transform.
Yeah.
So every operator has its own module in which it has some types, and eventually it's tied into observable with this method that is actually used by users.
Yeah.
So back to map. Here's the core observable subscribe. Takes that wrapped context, transformed, and then the source as well, and subscribes this wrapped to the source. Subscribes this wrapped to the source.
Yeah.
So this becomes a subscriber, right? An observer, an observer of the source.
Yeah.
And if we scroll a little bit, we will find tests. That's it. Happy?
Yeah. Yeah, I'm good.
This is probably the fourth time I'm looking at this implementation. Maybe sixth.
It is a little bit difficult, yeah. But I think I expect map is not one of the very difficult ones.
Filter is much the same as map. It's very little
Except
difference. Like
like you can
literally, this stuff is the same. Filter is just different by name. Of course, the function signature is different, right? Because it needs to like return a bool or something. Here,
yeah.
it's like takes a reference to the item instead of an item and returns a bool. And then next decides whether it should call next according to that. Again, this parentheses self.filter calling with
Yep.
ref v.
So it calls the observers next if the filter returns true. Yeah.
The rest is again pretty much the same and is
Yep.
just. So, and of course there are more complex ones. And then pick one. Do you want one to that collects state or merges between two different observables somehow?
Yeah, let's check flat map.
Oh, you're doing a steep curve here.
Yeah, it's the ultimate operator, yeah.
I don't mind because I've been
Do you
reading
think
this for a
there's a
while,
bit
but
like something in between?
yeah, I think so. Like reduce,
Yeah, okay, let's check reduce. That sounds good.
it keeps state, but doesn't do anything fancy with observables, right?
Mm-hmm.
Oh, but it is generic, apparently. Defines the strategy for executing the reduction logic.
Oh, seeded versus unseeded. Great.
So there's the
Strategy.
straight
Strategy. Really?
strategy.
Strategy.
This is similar for retry. There's a retry policy.
Hmm.
So
Interesting.
it has generic on ACC and the item. The arguments, of course, is the accumulated value. None indicates the first element for unseeded reduction. Oh, that's like a special. What do you mean none? I want to see. I want to see what this is. Value is the next item. Okay, and it has a function. It needs the function apply that takes ref mute self, which means self is the implementer of reduce strategy. So it keeps the no here it so it can also keep state, right? Self can keep state. In addition, the self can keep state because ref mute here. There is the actual accumulated value. Does that make sense? And I think it makes sense because right, but with reduce, actually I don't know what I'm saying.
You need to remember the accumulator. What is this trait implemented on?
We don't know yet. Yeah, we need to like see a usage.
Yeah, maybe check usages.
And there is probably an implementation of it for like function. Like this one. Or reduce initial function.
Ah.
We will
Reduce.
see. What do you want? Do you want to see the tests first, or do you want to read more?
No, that's fine. That's fine. So
Here's an example.
yeah.
Reduce initial for some reasons here. Why? The heck is going on here? I thought that this is reduced. Are there two methods here? There are two methods.
Yeah. Reduce and reduce initial.
So these things are not even public, are they? Where's this trait?
They are public.
They are public. Okay. So this is generic because there are two methods that basically do similar things. They share some of this implementation. Here's reduce. And you can call it with a closure that takes ACC and value and the usual thing, right? Returns the new ACC. And in this case, we can see that the ACC is the same as the item type. That's true here as well, right?
Yeah.
And that's true here as well. That's what I kind of know from reduce, right? But this is not the case here, is it? This is reduce initial. What is going on here?
Because it can't be the same, because one of them's string and the other one is usize.
What does reduce initial do though? Apply an accumulator function with
provides
initial
an initial
value.
value.
So this
The
is
zero.
the initial value.
Yep.
So as long the initial value can be different as long as that is handled in this closure.
The initial value can be different if it is provided. If it's not provided, then.
But it can't be. It's the same as this. The ACC.
It's the same as that. Yeah. But the value is a string.
I see. So the value needs to be the same as the source item.
In all cases. But
and
if
the
you want the
initial value needs to be
accumulator
the same
to be
as the
different,
returned and the accumulated. Okay.
Yeah.
Okay, fine. Okay, so we understand the two signatures.
Yeah, I'm more curious about like ownership and stuff in this reduce.
Okay. So after we saw this trait reduce strategy, it can be implemented. Let's see its implementations. There's a struct reduce function, which is for the reduce method, I suppose. Public on generic on F with a pub F. Impl F and item. Reduce strategy of item. That's interesting. Because it's the same. Without a seed, it's the same. The two types are the same. For reduce function of F, the F is as expected, right? Takes two items, turns an item. Are you reading ahead of me or behind me?
Yeah, I'm with you.
Okay. Function apply takes ref mute self. Again, this I don't know that it's actually using self mutably here. That's not what I'm saying, right? But for some reason, it's a ref mute self. I think this could be.
Yeah.
Oh, it's mutable because calling an fn mute. Okay. This is the fn mute, right? Calling an fn mute is a mutative thing.
Yeah.
So that's why it's ref mute self. Does that make sense? So
self.0
match on. So apply takes an ACC. There's an option. That's because of the first time, right? First call.
The first call.
First call. Value is an item and returns, and also returns an optional item. And that I don't quite understand what's going on there. Is that for like ending?
Uh,
For ending the reduction early? I bet it is.
it doesn't actually return a none anytime though.
Does not return a what?
A none. It returns some in both cases.
Well, but you could implement your own reduce strategy.
Um,
Is that right?
Maybe. Scroll down, let's see the other one. Does that return none? I mean, reduce initial fun.
Okay.
It's just a map.
Well, here there's ACC an item and ACC item. Takes ACC an item and returns ACC. This is option of ACC instead. This value is item, it's the same. This option of ACC. And this ACC is always some because it is initialized with the seed. So we just map it. We could even unwrap it, but we map it because
It's cleaner.
we also need to return an option.
Yeah.
So we just apply the function, whatever the function is, to the ACC and the current value. And here's the operator.
That's self.0.
It's a function.
The function itself.
Yeah. This is in these two structs, reduce fn. It's there are tuple structs that have a single positional field. F.
Okay. Yeah.
Yeah. So this is where this one is called.
Why is it pub?
It's a good question. Why is this pub?
No, why is
that pub?
Argument pub, yeah.
I know. I don't know why this pub either, because the user does not do this, right? The user calls a method that is somehow associated with this. We saw. Maybe we didn't see. But the user does not construct this. Right?
Okay.
So here's the reduce operator returned by the reduce method, I suppose.
Oh, it's an argument in this reduce type, which is public, because this is what the function returns. So probably that's why it's public, so you can read the type. Because this needs to be public as well.
Yes, but I don't know about the field though.
The strategy.
Yeah, the function itself, I don't know why it is public. You're right about the strategy, yeah. So there's, as usual, or as common, there's a source observable. The strategy is kept as a field as well, and apparently, yeah, the initial is here because it's provided when this is constructed from the method, observable method. And this is the impl S strategy accumulated observable type for reduce of S strategy ACC, where the only bound is that S is an observable type so that we could grab its item.
Which is an ACK.
It's ACK, right? It's not S item. It's ACK. And air is S air because reduction does not change the type of the air.
Yeah.
Cool. And then we have the core observable implementation, S strategy C and ACC. Core observable of C for reduce of S strategy in ACC. Where C is context, of course. S is core observable of. Now, check this out.
C with.
Yeah. So with is an associated type of C, which is a context. So a core observable is generic on a context. And it's the same context as this.
The source. Core.
Yeah, the source is core observable.
Yeah. With core observable of distinct contexts with reduce observable of distinct context inner type.
Observer. Reduce observer.
Observer, yes, observer. Yeah. Okay.
That's the source of the core observer. So it's not the inner.
It's not the what?
It's not this is the inner, right? So there's inside the core observable, there's a reduce observer, and inside that there's like whatever the inner is.
Yep.
Inner observer, I suppose. Strategy. Is a for lifetime A reduced strategy of ACC and S item of lifetime A.
Is this the concrete reduce strategy? The reduce initial strategy or the generic one?
This is the trait reduce strategy. It's a trait, not some struct that implements reduce strategy.
Right.
Not
so it could
not
be
initial,
either.
not seed.
Yeah.
Sorry, not, I don't know what to call it. No, not reduce and not reduce initial. This is the trait. And this also takes the ACC and the S item. And then there's unsub that comes from the source. Function subscribe, consume self and context, and returns in self unsub. Destruct self. Again, self is just a conveyor belt for reaching here, right? I mean, it can, it doesn't necessarily reach here every time, but like.
What do you mean it doesn't reach here?
It doesn't necessarily, like a self does not, because you can construct an observable and never subscribe to it.
Right.
But if you do, this is where it gets. Its fields are obtained. And again, this transform utility And here the observer is constructed, wrapping the previous observer, right? Like from here. That makes sense?
Right.
And the strategy is stored here, and the ACC is set to be the initial we already got from the from self. Can be none, or it can be some, depending on the method you called to obtain that self, right? Source, and then we do source subscribe. We subscribe the wrapped to the source. Observable. Again, this is an observer. This is an observer. It's a context, which is an observer. It's a context.
What I find a little bit hard here is tracking which way the signal goes.
Yeah, data flow here, and what wraps what.
Yeah, because sometimes things are wrapped where the inner thing is the source, and sometimes it's the sink. Yeah.
Okay, so here's what so far, if I can like ponder on it, is so far what I'm able to do. I think for that we need to like distinguish the construction of observables as one thing that occurs, right? The construction of observables, and that an observable can like using like operators, all sorts of methods, consume observables and return another observable that wraps them.
Yep.
Right. So that we have observables inside observables inside observables. And that's one thing that occurs in this API. Another thing that occurs in this API is subscription.
Yep.
But it does not necessarily occur. But when it does, so during construction, here's what happens, right? Where like we can split this up and go to observe. And what is this? This is reduce. Okay, so we can go to observable, and we can find fn reduce, right? So what happens is that it consumes self, right? And what is self?
It's an observable.
That's right. And then it returns this, right? It returns this self transform, right? The context transform, and you end up with this. What is the source? Also an observable, right?
That's the original observable.
Yep. You reach it via the context, right? The existing context. Self transform, you get the original observable, and you wrap it with this new observable, right? Like this. So that's all that happens when we do these methods, right? These, as long as we don't subscribe, this is all that happens. Observables wrapping observables. Is my observation correct? What do you think?
Yeah, I think so.
Right. But then we subscribe at some point, right? And that's when things get like something different happens, right?
Yeah, we go the other way.
Here is a subscribe for core observable. Is core the subscribe it is part of core observable for reduce, but we can like start in observable fn subscribe. right? This is, I think we want context subscribe. What is it? Observable. Yeah, observable subscribe. It happens in observable subscribe, which is what just one of them, because there's also subscribe with and so on. What happens there is that the observable is consumed, right? And an observer is provided in the subscribe call. This case is just a function. And then whatever this does, right? I don't think it matters. It's like, I don't know, this like takes the observer. This is a function mute observer that is constructed here. It's associated with this method, right? Subscribe that takes a function, constructs a function mute observer, but the user doesn't get that. Okay?
Yeah.
The user doesn't get the observer. No, this is constructed and then lifted into a context to become a context, right? So an observer becomes a context, lifted into a context, and then the subscribe method is called, right, on the core observable obtained from self, which is an observable. Does that make sense?
Self is an observable.
Yep.
What's the into inner?
Into inner apparently gets us the core observable of it. It's a method on context that gets the self inner. So it's the core observable inside the context. And then we call subscribe. And then this is where like the context shifts, right? Because now this is without context because we call into inner, but the observer has the context. Does that make sense? Because here we have wrapped the observer in the context. And then this observer is now subscribed to the observer. But what happens, right? Like we need, that depends on the implementation of that observer, right? So we can take a look at function mute observer. This code I never read before. Function mute observer has
blanket implementation of observer for closures.
Well, this category is that, but I mean, this is a struct. It's not a blanket implementation. There's probably a blanket implementation somewhere here. I don't.
Yeah, just below.
I think in a way it's a blanket implementation because this F is generic. Okay, so a blanket implementation in Rust is like not exactly this. It's more like literally impl. There is no struct here, right? There's only F, right? And then you say where F is some bound, and then you can implement stuff, okay?
Yeah, so this got extra steps.
This is a generic implementation. Of course, this is semantics, right? But like when I studied what blanket implementation is, it's not for a type. It's for a generic, and then there's a bound.
Right. The authors seem to think it's a blanket. But it's not exactly.
So this observer, you see its logic, it doesn't do much, right? It just says, here is how this type can observe, when it needs to be called, right? This next stuff, error stuff, complete stuff needs to be called by something else, right? But the producer, right? This is a push mechanism, right?
Yeah.
And because it's a function, it's a function observer. It just calls that function. That's what it does, right? It'll just call the function with the value. That's it.
Yeah.
And it must be infallible. So I guess
It is infallible.
It's fallible. It ignores errors. So basically, doesn't do anything for error. Complete, that you can't, when all you provide is a function, you can't, it's when you don't mean to handle errors, you don't mean to handle complete. And maybe this is like never closed. Maybe this is concerning whether the observer is closed. That's interesting, right? Not the observable. I'm not familiar
This
with
is an
this.
observer implementation.
Yes. So we can get back to reduce and take a look at what happens observer, right? Because there will be a subscribe here, and it's the core observable subscribe, right? It's like something calls this subscribe, and it's not it's not us. I think it's the context does this, passing itself.
Which context?
The context. Because I don't see any more subscribe calls here. There's like this and that. That's it.
Don't we ultimately subscribe to something in the app?
Yes, we do.
Yeah. So that's what starts the subscription chain.
Yes, and we saw that here, this on observable, this is like public API observable. There you can subscribe with a function like this, or you can subscribe with a full observer implementation, with subscribe with. You can do other things. You can convert the observable into a async stream. What's called an async stream, or into a future. So there's multiple ways to subscribe, but this is like the simplest one,
Async
right?
stream. What
Yeah.
the hell is that?
Rust async stream.
Oh. So stream is like a simpler version of this that doesn't handle errors, completions.
I don't remember
And
what the
starts.
semantics of stream is.
Probably has a next, but no is complete or error. But who knows? Okay, so you can subscribe an async stream. Can you subscribe a file to it? So I'm some kind of file writer.
No, I don't think rxRust provides such an API, but you can, you can do an implementation. Because what is
So
this?
you could
Subscribe with
mhm.
observer is O. And the constraint is that self inner is core observable of self with O. Sorry.
What about the as?
I'm
In
still
the
trying
type,
to
it's
answer the question of like the data flow, right? So this subscribe, for example, calls this subscribe, the core observable subscribe, right? It again shifts the context to the observer by doing this lift and yanking the inner observable out of the context. And the calls subscribe on the core observable, the inner core observable. Now, what if the inner core observable is a reduce, right? This is the core observable implementation for reduce, right? So this is the subscribe call.
Yeah.
So what does this do? When subscribe is called,
It calls the subscribe of the of this one's inner observable. Of the source.
source observer.
Observer.
Is that right? Reduce. This is, what is the source?
Yeah, the source bound is not here, maybe.
Yes, but it's an observable.
No, it's a
This
core
is an
observable. Yeah, 91. Source is a core observable whose a core observable with a reduce observer whose source is this context's inner. Yeah, okay. So let me check if I understand correctly until now. So we build up pipelines by going from source to sink and calling various methods on the source like map, reduce, etc. And calling things on those observer roles results observable method results, which are also observable.
Yep, observables, wrap observables, wrap observables.
At a certain point, on the last thing we get, we call subscribe or something to that effect, and that in turn calls subscribes all the way back, now going from sync to source. So the last thing calls the next to last thing subscribe, and the next to the last thing calls the next to last thing subscribe, all the way back to the first thing.
But you started by saying that we wrap things and there's sync and source involved. But when we wrap an observable in an observable in an observable, these are all sources. There are no syncs involved.
Yes, when we build the thing, there are only sources. Well, a sync it's not really a sync, but it's like the next processing step, let's say.
Yes,
but it provides its results as a source.
The term is observer, right?
Observer.
There's observable and there's observer.
So you build up observables.
Right.
And at the last moment, you
subscribe.
Sort of flip a switch and subscribe, and then everything turns into observers. And
into
the arrows fade the other way around.
Into observers that subscribe.
Yeah.
Each one to the inner one. And the subscribe is an effect.
Yes.
It's an effect.
It also starts the source. Like if you have like an iterator source, when you subscribe, it starts spitting out values, right?
Yeah, that's called the producer.
And producer's an observable, right?
Yes, like
Mhm.
the observable that actually produces values.
Mhm.
But okay, so this is where you've asked the question. I want to be more accurate. I think from so far from what I've learned of Rx, there is the concept of a hot observable
Mhm.
and a cold observable.
Mhm.
And some observables are just hot, like as soon as they're constructed, they don't need a subscription. They don't need an observer to subscribe to them. They just start producing values, right?
Mhm.
Like if there's something that already is going on, right? Like you observe some hardware, some sensor.
Yeah. Yeah. Yeah, like
It doesn't
mouse
depend
movements or
on,
something.
right? It's hot. It's a
Yeah.
hot observer.
Mhm.
But if you do something like a factory, like
A list,
from
a
iter,
vector. Yeah.
then it's a cold observable. There's no point
Uh-huh.
wasting those values until there's an observer.
Yeah, so it's gonna wait until you subscribe to it to start producing values.
Exactly.
But then it becomes hot.
Yes.
Then if you unsubscribe, can you unsubscribe from a formatter?
Yes. Yes. And observables have these methods, right? Like what happens when there's subscription? What happens then when there is a unsubscription? I'm
Interesting.
not sure what trait that is.
Unsub, maybe? Something to do with unsub.
Yeah, maybe unsub is a trait. I don't know.
Um, when does subscribe return? Because
Subscribe returns.
subscribe returns an unsub.
Yes.
Yeah, so I think it should only return when.
And look, unsub is bound by subscription.
Oh, okay. I
Right?
don't know what
Here's
the
the pub
subscription
trait.
is.
Core. So here, basically core observable is subscribe method that returns a self unsub because whatever subscription that is, subscription has unsubscribe, is closed, and unsub. Interesting. Whether, like, how to decide whether to unsubscribe when it is dropped, which is an interesting concept.
Okay.
And if you want to create a relationship between the observable and the subscription, because there will be in different places, then you need to do it via some shared data, right?
The observable and the subscription.
Yeah, because the caller, if I get back here, right? The caller calls subscribe, obtains a subscription, and an effect starts occurring. The only access that they have into like unsubscribing is this value. So this value must, if it's actually if it is actually to successfully unsubscribe and like shut some switch off that stops doing some effect, like polling something or reading something,
Okay.
then it must have some
Yeah.
access to do that, to reach back to do that. So that will be some kind of a shared mutable reference, something, or a channel that can set a signal to a different thread.
Sorry. I gotta go for a sec. I'll be right
Sure.
back. Hi.
Hi.
Yeah, I almost fell for a scam call there.
They almost got you.
Yeah.
Oh no.
Okay,
I'm
let's get back to it.
mm-hmm.
So, for example, you can call subscribe, and subscribe returns an unsub value. Does
So
it return the unsub value like immediately after you subscribe, or only when? And you can use the unsub value to.
so I think that depends on the observable chain and the final producer. Because I think that I'm pretty sure that some observables will blockingly emit, right, all of their values, like from iter. I think it blockingly emits all of its values on subscribe, which means when the subscribe returned, all the values were emitted. Does that make sense?
Yeah.
So the entire thing already occurred.
Okay.
Of course, that depends on like whether you have only blocking operators, right? Because you could
Yeah.
have operators like a delay, right? And then you're in a different world, right? Well, it's funny.
No, it's just reactive
It's okay if
programming
it's funny.
seems simple until you try to actually work with it.
Mm-hmm. Okay, so popping the stack back to the data flow, right? Observation.
Yeah.
That how did I get here? That as soon as subscribe is called, an observer is provided in the subscribe call, right? You can't subscribe without an observer. And then it's like the whole chain is turned into a chain, is consumed and turned into a chain of observers wrapping observers instead.
Yes.
I think. Or maybe it's observers wrapping observables that wrap observers. What do you think? So here's a subscribe of reduce, right? We've seen this a few times.
Yeah.
And this context is actually observer, right?
What?
Yeah, because look, here's the external user-facing subscribe
Yeah,
call.
yeah.
Observer, right? Okay.
Yeah.
So now we're going, where did I get? Reduce. Now we're going to this core observable subscribe for reduce.
Mm-hmm.
It's a subscribe of reduce. And what happens here is that we obtain the observable and it's source. So that's an observable, right?
Mm-hmm.
Where does source go?
We
It is
subscribe.
consumed and turned into a subscription that is returned.
A
And
subscription.
subscription wraps the observer. Okay, a subscription wraps the observer,
Mm-hmm.
and then that observer probably wraps a subscription that also wraps an observer that also wraps a
Mm-hmm.
subscription.
Mm-hmm.
I think that's what happens. Or
So
some
when
idea.
you build the stuff, you're building observables, but then you call subscribe and everything gets turned into observers.
Yeah, and into a subscription that
And the
wraps an observer.
ownership or the wrapping is like it's inverted. Now the outermost thing is the result, like the end sync, and what's inside it is observer. No. No,
Yeah, the
the
subscription
outermost
owns.
thing is the first, like the producer. And
No,
inside
no,
that you've
no, that's not true.
no?
No, because you subscribe to the last observable that you got, right?
Yeah.
So that's what you have
Yeah.
in the API.
Mm-hmm.
This is the core observable of reduce. Maybe that's the last thing. So you call subscribe
Yeah.
on context that has this, and then that context is passed here. I mean, the observer is the context now passed here. You break this observable apart. It's broken apart.
Yeah.
You're only interested in the
The
source.
source.
I mean, its own observer. It's turned into an observer. That makes sense.
Yes.
Here is an observable. It's broken apart. It's converted into its observer
Yes.
and subscribed to. Oops. And then the subscription is returned.
Mm-hmm.
And the source that the observable already had is now
It's no more.
well, yeah, it's consumed by the subscription.
Yes. And all you get is a subscription which wraps the observer.
Yes.
This observer. Like the
It's wrapped
reduce,
in
in this case, the reduce observer.
yes, and the subscription is actually wrapped in context.
Yeah, okay.
There's the whole context part of this.
Context with reduce observer of inner context. And the inner context, in turn, is the source turned into an observer. No.
This inner context.
So wrapped is C with
C is context with reduce observer.
reduce
Yeah.
observer. Yeah. And the observer inside the reduce observer, like the observer field inside the reduce observer.
Yeah. It's the inner from the context. It's the observer, right?
Mm-hmm. Mm-hmm.
So
So
that
it's
is
whoever subscribed to this reduce, right?
yes.
Mm-hmm.
This returned observer in the return subscription needs to have its its like the first observer, right? Like or the previous observer, or
Okay,
like
so
the
the
previous in
observer.
terms
So say
of
we're working on reduce now. So the observer here is the thing that gets the values from the reduce observer. So like the observer is the out or the next step or the out, the result.
in the order of construction, it is the first observer, but in the call, right, the value flow, it'll be the last.
The last. Correct. Okay. Okay, so yeah, it makes sense. Okay, so when we build the stuff up, the from data flow perspective, the receivers are wrapping the senders, or it's observables all the way down.
Observables, yeah.
And when we call subscribe, this gets turned around, and now
Observables turn
the
into observers.
observers own their downstream observers.
Yes.
Yes. Good.
And observables turn into observers.
Mm-hmm. Inside out. And this whole thing is like a graph, right? Where values can split and merge. But
Right.
are there circles in the graph?
There can be circles, but like you need to do fancy things like with channels in order to implement those.
Mm.
Or with there's this thing called the subject. But hey, let's not I don't know, let's not push our understanding here.
Okay. Well, okay, so I think I got the data flow, and I think I got the construction and subscription and
Cool.
ownership stuff. Yeah.
Shall we look at more operators then?
Yeah,
Maybe
I
one more.
guess yeah.
We saw
If it's
reduce.
only one more, then it has to be flat map.
No, no, no. No, 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 no.
You mean one more before flat map?
Let's just not think about too far ahead. How about something like delay?
Yeah, delay.
It's simple. Like it's pretty much the simplest thing you can do with scheduling. This involves scheduling, okay?
Yeah.
So we have this delay observable struct that returns from the operator. I mean, I guess it starts with the observable right function delay, right?
Yeah. Give it a duration, and
That's it.
returns a self with delay inner.
And self scheduler, because context has a scheduler, right?
Mm-hmm.
This is scheduler on the context. Associated type scheduler.
Mm-hmm.
So the
Error and
scheduler.
completion notifications are not delayed. But then maybe you have successful values, you didn't receive them yet, and you get an error or completion, but you still have values in flight. That's weird.
Mind if I don't care about that right now?
Yeah, go ahead.
Let scheduler we clone. So schedulers, the scheduler must be cloned for this. I suppose their provided schedulers are simply clone. Okay.
Mm-hmm.
And here is the self transform. Okay? Take the core observable from the context and construct this delay struct. Source is the previous one, right? Core source.
Mm-hmm.
Here's the delay and the scheduler. Okay, so we have this operator. There it is. Observable type for it is stupid simple, right? It does involve the scheduler. I don't even know why, only because delay must take a scheduler type.
Mm-hmm.
But it's not used there. So type item is s item and air is s air.
Mm-hmm.
Here is a subscription type and a delay state, whatever. Here's a delay observer
Mm.
that takes an observer P.
P
I don't know what's P.
producer.
scheduler.
Scheduler and a state R.
State R, yeah, okay, yeah, let's see.
Okay.
Here's a standalone function, delay next handler. Not so simple. Static handler function for delayed next emissions. This is what, I think this is what given to the scheduler.
Oh.
The task state includes observer item state ID. On completion, the task removes itself from the state using its ID.
Okay.
P item, air, and R takes us. Well, let's look at this when it's used.
Mhm.
Here's a delay complete handler, which is also probably given to the scheduler. And here's the observer for delay observer, okay? Or do you want to start from the, maybe start from the subscript core observable? So this is what happens when we subscribe to this.
Yeah. We create a delay. Create a
Destruct the delay.
Destruct the delay. Create the destruct.
Yeah, destruct.
Destruct.
Here's self.
Oh,
This
destruct.
is
Yeah,
subscribe.
Got it. Create a state which is a reference counted mutable.
Yes. Now notice that this is, yeah, it's like this is another utility of the context. It's an associated type of the context. So the context provides this facility of obtaining RC mutes in a generic manner. Like each context provides its own.
And it obtains this RC mute from delay state new. Oh no, it creates a reference counted mutable state something from delay state.
Yeah, it's just a wrapper, right? This is
Can
just
we check delay state? Yeah, delay
yes,
state.
yes. So here's delay state. It's this comes from rxRust subscription dynamic, so it's a shared utility here.
Dynamic subscription of task handle. Oh dear. Type alias for the delay state collection of pending task handles. Dynamic subscriptions. It's next ID and items. Yeah, okay. Small vec.
Yeah, sounds like an optimization.
Okay. Yeah, okay. So the delay state stores the delayed
Empty one.
task references to the to task. Why task references? Why not whatever values?
I think it's because it's like you get emits, you get one, you get one, you get one, you keep delaying. And then I don't know, we'll see. It's like it looks like a buffer, right?
Yeah, but it holds tasks, not values. That's the weird part. Anyway, let's continue. So we create a delayed wrapped thing.
Yeah, this is where
we transform the context into a delay observer. We pass the state. What? The observer is now a mutable reference counted mutable.
Yes, because it needs to be handed, right? A clone of this needs to be handed to the schedule, like as a task, to the schedule as a task.
Oh. Okay.
See, this is where
why an option? Was it
an
some
option? For the case of unsubscribing?
Okay.
Is this making you happy?
For sure I'm learning stuff, and that
Me too.
makes me happy.
Me too. So the scheduler and the delay and the state is simply cloned from here, from the RC. So the state is also held in this RC mute. So both the state and the next observer, right? The next observer
Yeah.
are RC mute stored on this, sorry, wrapped. And then
Subscribe to the source, and then
there's a regular subscription, but then it is wrapped
okay.
in a certain helper here that comes from rxRust subscription. There's a special subscription called source with dynamic subs. Subscription combining a source subscription with dynamic subscriptions. When unsubscribed, all dynamic subscriptions are drained and unsubscribed first, then the source subscription is unsubscribed.
Okay. So there's a source. And there's another thing, which is a state. And
yes,
we combine those and return them.
That's the observer. Now, we should take a look at the implementation of observer for it, right? This one.
Yeah.
Because the observable will be calling, or the observable will be calling next on these, right?
Yeah.
Observable will be calling next, and this has 5, right? Generics with rate bounds. And here's what the next does, which is from the self state, it obtains. Oh, there's this. It obtains a mutable reference, right? This, because you see it's. I don't see like an unwrap here or anything like that, and it just blocks until it gets one, right? I suppose. Okay, you want to do there is no documentation, but yeah, this just blocks until it obtains a mutable reference. And apparently, this dynamic subscriptions thing, the state, has a reserve ID method. Gives you a usize. Reserve the next ID without adding an item.
Yeah.
Use this with insert when you need the ID before the item exists, e.g. for cyclic dependencies in observer patterns.
Okay.
So an ID is reserved, you get it. Let task state equals, this seems to be a tuple with 4 things. Cloning the observer, the next observer. Okay, are you following?
Yeah.
Cloning the next observer. Providing the value as a sum. Cloning the state as well.
Okay.
The state that we just reserved an ID in, right?
Yeah.
And the ID that we just reserved. And that was what we call the task state, these 4 things.
Okay, but
and then we create a task passing that tuple. Okay? The task is a type here. So this is a generic. No, it's a struct from the scheduler module.
Windows state with execution logic.
Concrete. I mean, it's generic and it's generic on state. Okay. So all schedulers, right, take the same task type. This one.
Yeah.
And we construct this, whatever, this S state here, all these 4 items, and
the delay next handler.
this is a function
message.
call, right?
Mm-hmm. No,
and
that's
it's not a function
reference.
call. It's called a function pointer.
Pointer. Okay. Reference.
That's what it's called. I remember this is a function pointer.
Huh.
Static functions.
They had pointers in Rust.
Well, there are actually in unsafe Rust. Yeah, you can get a pointer.
In unsafe, yeah.
Using it, dereferencing a pointer is unsafe.
Okay.
Let's not get into that. So anyway, this is a reference function pointer, which is different than other pointers. A function pointer, and it's made concrete with. I think it's basically this items of the task, right? No, it's different. It's P item, air, and R. I think this is R.
Yeah.
No, R is a deref mute of blah, 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 blah. So that's not R. R is a deref mute.
Oh dear. Task can have 3 or 4 type parameters.
Why?
Look on line 113 and 114.
That's just because it has a default. No, it's a tuple. It's not about task. It's just one. It's a single type argument. It's a tuple.
Yeah, my bad.
Okay. So we construct this task.
Yeah.
But we haven't, in constructing this task, we haven't yet provided a delay. So that's not yet the case. It's here when we do a self scheduler schedule. That's the task that we're scheduling.
Mm-hmm.
And here's some self delay.
Yay.
So delay is easy to implement relatively because schedule method takes a delay.
Okay.
But you still need a bunch of wiring, right? All this stuff. And you get this handle. And then what do we do with this handle?
Put it in the state.
And when the task is done, right? This function, and that's next, right? The value, right? The value for the next observer, along with, right? I deref mute to the next observer. To what is this? Delay observer? Whatever this is. It's like some kind of an inner observer, right? Self observer. No, that is delay observer. So basically, delay observer is clonable.
Yeah.
There's like, what is this? It's like self. This is delay observer, right?
Yeah.
So what does delay observer have? A P. And P here is some observer. Oh, so it's not. So why does it say that this is delay observer? Can you explain that?
Self is a delay observer. Why is observer a delay observer?
Self is a. No, you're right. I'm sorry. No. I was reading wrong. No, it's just P here.
Oh.
I was reading wrong.
So it's an observer of item and error plus clone.
That is clone. Okay. Yeah.
So it needs to be, yeah, if the observer needs to be cloned, it means the item and the error need to be cloned as well, if I remember correctly. So you can only delay clonable items.
There's no reason for that to be the case, no.
No?
Because if you delay an emit, there's only still one emit, right? And here
Yeah.
it's passed by value over to that task state
Yeah.
from here to there.
Okay. So how do you, oh, you can clone the observer without cloning the value.
Yeah. I think in practice, many observers are cloned.
Mm-hmm.
So this just happens to be a trait bound here because it's necessary, but in practice, many of them will be cloned, I think. I don't know. And this is the handler of the task, right? It's a static function. So that's
What
right
to do?
after the delay, but not exactly after the delay, right? Like there's this best effort, at least that delay, right?
Yeah.
You get this function called with the state and all of this. No, that's it, right? It's a mutable reference to all of that. Interestingly, you don't get the function doesn't get the actual value by value; it gets the mutable reference to it. Maybe that's has to do with like the IDs. So
mutable reference to a tuple is mutable references to all the members. Is it?
yeah, in practice it is.
In practice, okay.
It's not a mutable references to all, inside that there is one tuple in memory, right? Tuple is a consecutive piece of memory.
Is it a tuple of mutable references, or
No,
is
no.
it a mutable reference to a tuple?
It's a mutable reference to a tuple, which is a consecutive piece of memory, sized memory, known sized memory.
So you can
and
change
you are
this
the
stuff
only
inside.
one. Yeah, if you have the ref mute to that tuple, you're the only one who has the ref mute to that tuple.
Okay.
But in practice, that's why I say in practice, because look at the type system. What we do here is destruct, right?
Yeah.
Destruct that tuple, and each one is a ref mute.
Yeah.
So it's like none of this is real, right? This is only borrow checking.
Okay.
Does that make sense to you? Like borrow checking is not, how do you say? There's no implementation, right? There's no machine code for this borrow checking.
Yeah.
It just makes sure that you produce machine code that is more sound.
Yeah, it's part of the type system.
Okay. So if let some item from item op take, then the next observer gets that emit delayed, right?
The delay is because this handler
function
only runs when the scheduler schedules it.
Yeah.
Okay.
And then there's this state RC deref mute. We get right. We get, because we have the ref mute R, which needs to be a rcdref mute. Target is delay state. So if you call rcdref mute, you get a ref mute delay state, and then you can call remove the ID. Why?
Yeah.
I don't know. Maybe for unsubscription, right? For this deal, you remember the dynamic subscription? Sorry.
I'm sorry. I think you need to remove the entry from the buffer, so you don't consume memory for all of the items that you already delivered. Because the state stores a task handler for each in-flight delay. And when
Don't
you
you expect
handle
that
it,
kind of thing to be handled by the scheduler itself? Like, why would a scheduler?
but the scheduler doesn't know about the state. The state is inside the delay observer. Yeah, the state is inside the delay observer.
Delay state is actually dynamic subscriptions
Yeah.
of task handle.
Yeah, but dynamic yeah.
So I bet in the unsubscribe, right? Here's the unsub. It's this. So in the implementation of unsubscribe of this thing, right? It's
Source with dynamic subs. Okay.
Here, subscription, unsubscribe. Okay.
Mm-hmm.
It will do a unsubscribe source first,
Yes.
which is whatever it happens to be, and then self subs rcdref mute unsubscribe all, which is like, I don't know, just synchronously. Oh, self drain. This is vec or something else? Drain is impl iterator. No. Drain is that methodon. But this is small vec drain, so.
Mm-hmm.
Yeah. Okay. Obviously, there's more to like study here, but I'm quite pleased. Are you quite pleased?
Yeah. Yeah.
Cool.
For sure. Yeah.
All right. So let's call it a night.
Yeah. It's been 2 hours already.
Mm-hmm.
Okay. All right. Well, in today's edition, we reviewed a bunch of operators.
Yes.
That's pretty much it. Okay. Well, thank you, Don. I guess looking forward to next week. I guess we can get to some implementation, perhaps. But this was also fun. We need to do some learning as well. Thank you for the intro and the explanations.
While 99% of software developers are practicing their, what is it? Prompting skills?
We're doing reading skills, back to the basics, but reading type.
Thank you, Marton. Don't hang up.